Hi, I'm Scott Hanselman. This is another episode of Hanselminits. Today I'm chatting with Adam Jacob. He's the CEO, co-founder, chairman of SystemInit's, and the co-founder of Chef, where you were the original author of Chef and you were the CTO at Chef.
Yeah, that's
so
true.
You're like all about the DevOps. Were you always DevOpsy, or were you a programmer who was like, we need a build server?
Yeah, no, I was always the ops side. Yeah, the history of that space is filled with people who hated the operations part, and they were like, the operations thing was the worst. And so I became a software developer so that I could make it so nobody ever had to suffer like I suffered. I'm the opposite. I love infrastructure. I've always loved infrastructure. I loved it when I ran bulletin boards when I was a kid. I love infrastructure now. Infrastructure is my thing.
Then we are people of a certain age, because I ran a Wildcat BBS on OS2 in my parents' garage.
Yes.
Isn't that delightful? And then
I too bought OS2 so that I could have multiple modems in the PC, and I needed to do that. I needed that delightful multitasking.
Yeah.
Yeah.
Oh my goodness. 2 big 14.4 hazes or whatever. And then the 19.2 V32 BIS. These are the times.
So fun building bulletin boards.
It was fun.
Bulletin boards were the funnest, and FidoNet was the best.
I was a FidoNet node as well. What a delight!
Yeah, I was the official. I was one of the seed nodes for the official Robotech network, which was like a Robotech devoted FidoNet network. While we're getting just nerdy about randomness.
Yes, classic cartoon. Enough people don't appreciate Robotech.
Yeah, when I was a kid, I was the keeper of the official timeline.
Seriously? Was it in ASCII in a text file?
It sure was.
Is it up on textfiles.com?
I have no idea.
You should go see.
I've actually never looked. I should
go see. You got to go see if Jason Scott has the official Robotech
timeline. That would be incredible.
Put that on the list of things to do.
Yeah, that would please me deeply.
That would be awesome. Yes. Mm-hmm. So in my software engineering life, somewhere, I want to say in the mid 90s, we were still releasing stuff from, a computer under Anna's desk, that's the build server. And then at some point, I was in C# in early 2000, we had buildserver.net, and we started making build.bat, and there were make files, and make files would run on a cron job. But when do you think build servers became CI/CD and then CI/CD became DevOps?
It's a tough call because it's blurry, the lines. I would say 2005 is probably when that began to shift by and maybe even earlier. I think I'm bad at dates, but I can tell you what happened from my point of view.
I'm also bad at dates, but tell me what happened.
Which was essentially, around the late 90s, early 2000s, we were all trying to figure out, now that you could get a lot of people to come do stuff on the internet, right? So the first problem was get people on the internet. The second problem was they need things to do. And so we started building stuff for them to do. And then when the stuff that they could do on the internet turned out to be cool, lots of people showed up all at once. And then we were like, oh my gosh, how do we deal with all these people who come to use these things now? Because we can't just run our systems like they were computer labs and we were shipping you floppy disks. And all of us sort of independently figured out what would become, CI, what would become some variation of CD. We had normalized build processes. We had, configuration management systems. We figured out how to deploy software, and we were all doing it in different ways. And so I probably wrote my first configuration management system in 1998. Right. And then, the first deployment system shortly after that. And then, had written 3 or 4 by the time I got around to using Puppet and then Chef. And, and I wasn't alone. And then Velocity, which was a conference that used to exist that Tim O'Reilly ran, that sort of spun out of the Web 2.0 Expo that was focused more on operations and performance, web performance. Was the first time that a lot of those people who had built those systems all got in the same room at the same time. And once we all got in the same room at the same time and started talking to each other, that's when you started to see vocabulary start to grow, right? Suddenly it was that thing we're doing, that's continuous delivery, that thing's progressive delivery. This thing is DevOps. And it was because all of those people who were very disparate before had no idea each other existed. We had no way to know if we were good or bad at our jobs other than the site stayed up, Suddenly we knew each other and it started to be more professionalized, and, To me, that's sort of where that happened.
When I started thinking about continuous deployment, I wrote a paper called Word Documents Won't Break the Build. And, the idea was that like some person was like, here's the playbook, here's the recipe. It's in a Word document. Like, hey, you want to learn how to build the software? First, get this Word document. And then someone would change the document and they would get mad because the build would not break because they had changed the policy. They changed the recipe.
Yeah, for sure.
So you got this idea of infrastructure as code like pretty early. You figured out that Word documents and Markdown documents aren't easy to compile.
Right. And I mean, I had that idea. Like there were many people who had that idea.
Well, it's like the light bulb. It was invented multiple times by multiple people.
Yeah, a little. I mean, I think to me, we're all sort of standing on the shoulders of Mark Burgess on this front, where like it was Mark. Mark was the guy who wrote CF Engine, came up with Promise Theory. And, Mark's a professor and a scientist, and he's got, he wrote down the physics of why these things that we do works. And the rest of us are just sort of living in his universe, I think, to varying degrees of homage. But like, I think, the thing about infrastructure as code is that we started getting to this spot where we were like, as these systems grow in complexity, obviously the thing we need to do is treat the infrastructure as if it was an application artifact, right? And just adapt all of the same mechanisms that we adopted for deploying applications into the infrastructure, and that being able to write it as code would be good. And then we sort of fell into camps. There's people who are like real programming language people and DSLs. That was more me, Chef, Lumi, the CDK. Those things sort of fill that void. Then there was the like specialist language camp, which is, more Puppet, more Terraform, more Ansible, maybe a little more Kubernetes.
So Mark did this in like 93. So you're right. Like we've been sitting on top of the idea of like automating.
Oh, yeah. And Mark Burgess has been writing down how to do that and how to think about it and why it will work at scale in incredible notebooks, in perfect handwriting, and then publishing scholarly books on how to do it since then.
That's awesome. For 30 plus years.
Yeah. He's truly one of the most incredible people in computer science.
That's amazing. So one question I would have, though, is that it's the year of our Lord 2025. Yeah. And I don't know about you, but I bump into customers all day long that don't even have a decent build server. Like the idea that they could check something in and without fear go to lunch.
Yeah.
It's just like there's people zipping up source code out there. Like
we're doing all the crazy things. People
all
think
the crazy things.
Yeah, we like to pretend that we're not, but we are. And then even the solutions we came up with, don't work super great for most people. And, the analogy I use for infrastructure as code is there's a video game I love called Dark Souls. Have you ever played Dark Souls?
I have. And then Elden Ring and all the Souls-like experiences.
Elden Ring, yep. More people have probably played Elden Ring than Dark Souls. And the thing about those games is that they're hard. They're like ridiculously difficult. And you spend a lot of time just dying, just getting punished, just worked, right? I remember in Dark Souls being stuck on this one like knight. It wasn't even a boss, just a normal homie. And he just murdered me for like a week, And I felt as good when I figured out that pattern as I did when like my daughter was born. I was like, I had accomplished a task, and infrastructure as code is kind of like that. Like if you're a person who's figured out all of the knobs and pieces and all of the way that everything fits together, and you know how to put it all together just so, and then when it all snaps together, the machine runs, and you're like the crazy guy with the yarn, and because it was so hard and because you had to learn all that stuff, you're also convinced it was good, right? You're also like, and this was a fun time. And like for most people, it was not, yep, there is a particular human who like, oh, that's the best. And incredible. Good for us. And also the reason we're all still zipping stuff up and doing whatever works is because for most people, that's not a fun time. It's actually just getting punched in the face over and over and over again, and just never getting any progress, right?
I think of it as being somewhat Rube Goldbergian. If you're familiar with the Rube Goldberg problems, where it's like somebody, knocks over a domino and then that makes the bowling ball fall onto the iron and da-da-da-da. And I think that's art. And other people think that's insane.
I think it is both. It is art and it is insane. Like when you think about it from the point of view of being able to design systems to solve our problems, it's kind of bananas. Like from that lens, it's like we should be able to do better than we're doing. And we haven't been able to. And it's taken us a really long time to even come up with a concept of like what something else could even be. And, the thing about the status quo that is amazing is that it works. Like you can do it and it is art and that is great. And also, wow, that it works is kind of incredible. And, part of what I've been doing the last 6 years is the R&D to be like, okay, if I don't love the outcomes, and I don't, I taught a lot of people how to do DevOps, and I taught them how to do configuration management, and I taught them how to move into the cloud, and I taught them how to do a lot of those things, and they're all better off for it. Like they tell me all the time that they're pleased that happened, that their careers were better, like it's better. If you have those things, it's better to have them than not. And then they proceed to tell me, all of them, how much they don't like it. They're like, ugh, and this happened today. It was awful. I hate how this thing works. I hate how this thing comes together. Like it's literally the worst part of the stack when it comes to like the actual experience of doing the work. It's hard to collaborate with other people. It's hard to remember all the pieces that have to fit together. You get one thing wrong, everything breaks. The feedback loops are too slow. There's like compliance regimes that you're supposed to comply to, but you don't know you're out of compliance till you get an audit that's 6 months after you made the change that broke the build. And then you have to figure out which one did it. You can't figure out why because they have no audit trail. Like it's bad. And that's the stuff that I have been blessed enough to get to a spot in my career where I could like go think about that problem, like how do you solve that? And where that is such a big mess.
I've got stuff that I wrote in like 99 that's still on the web. Mm-hmm. And there's, I talk about bit rot. I was trying to explain to someone who's 5 years into their career what bit rot feels like. Yeah. And it's like, you got to have 25, 30-year-old stuff and watch it break. So like I haven't updated my podcast site in like 7 months, and I had a small change. And I was feeling quite clever. So I get the GitHub mobile app on my phone and I do a PR directly on my phone. I'm thinking, I'm so fancy. I'm doing a PR from my phone. Mm-hmm. And then I go home later, expecting the thing to be live. And I find out that some bits have rotted. Right. And it's like, this Docker base image is no longer appropriate. I need to use that one. And there's a Dependabot pull request about it. And I ignored it. And a certificate has expired and a personal access token because I haven't built this thing. And so do I need to like build it every day? Like bits rotted. It only took 6 months.
Right.
For these bits to rot.
Yeah. And then take that across the enterprise.
Exactly.
And by what we mean by the enterprise is the stuff that runs the planet, like the most important technology that runs the workloads that matter the most in your life, that are the least interesting in some ways, but that literally hold the world up. Like there is load-bearing infrastructure that's like that, like I was working at a multinational bank that no longer exists, actually. This is not why, but they ran credit card transactions in Brazil. And to do it, there was like a Brazilian banking reconciliation law they had to comply with. And they complied with this law by having a piece of software that was written in Delphi that was deployed on a Windows machine that was literally under someone's desk.
Boom.
They didn't know how to deploy it. They didn't know where the source code was. They just needed that machine to stay turned on so that they didn't go to jail, and they are not alone. That exists in every single enterprise everywhere on the planet. We just don't look at it. We just like to pretend that it doesn't.
We definitely do. I was, if you remember when CrowdStrike happened and the entire world like blue screened, I was in the Berlin airport, just hanging out, getting ready to get on a flight, and the airport blue screened.
Right.
It's just like, whoa. And it was just it was the most surreal thing. And it's like all the little things you don't think about. A buddy of mine, literally just before this podcast, texted me that something was wrong with his insulin pump. And we started debugging the firmware on some open source software that we use for our open source artificial pancreases. And the company that makes the insulin pumps swapped out the Bluetooth chipset and like didn't tell anyone. Ugh. And there's like this, you know what I mean? Like, and he just got a new batch in the mail.
Right.
And he could have just gotten on a plane and flown away. And he like never would have noticed that batch. And it's only iPhone 16s plus this board, plus Bluetooth, plus iOS this, and that insulin pump. And then they no longer talk to each other. And he'd been using this for like years. And now like this is like a full on crisis.
Yeah. Now it's an actual emergency. Like someone can die.
Yeah. It's not awesome. So then here's the question. You spent the first half of your career working on things like Chef, working on CI/CD, making things deterministic.
Yes.
Everything is about determinism, reliability. CI/CD, the D should be for determinism, not deployment.
Yeah.
But your new thing, SystemInit, is automated infrastructure with AI. And AI, when I think AI, the first thing I think is non-deterministic.
Non-deterministic. Yeah.
So that's insane.
Well, it's interesting, right? Because what's interesting about AI to me, like there's lots of analogies for how to understand it, but I think a good way to understand it is that the current crop of AI, LLMs, generative AI, whatever you want to call them, what those machines mostly let us do that we couldn't do before is they let computers be creative in a way that computers could not be before. And, they do that by building this giant map of all the data and putting it in relationship to other things and predicting the next token or whatever. But the capability that gives us is the ability for the machine to to do something creative that we didn't ask it directly to do, right? And that's kind of amazing. That's why you can ask it to a good example was I asked it to write me a Shakespearean sonnet about honeycomb the other day when I gave a talk at Honeycomb's observability conference. And I think I'm the first person who probably asked the machine to do that. But there it went, and it wrote a perfectly reasonable sonnet. And it's the non-determinism that makes the sonnet possible, right? If you tried to write a program to write sonnets, it wouldn't write very good ones, right? They wouldn't be clever. They wouldn't be interesting. They wouldn't be able to use the data about the thing I want to talk about. It's hard to write a deterministic sonic generator that feels natural. And yet LLMs just sort of creatively figure out how to do it. But they're not very intelligent, right? They're just, what they are is creative, which is a form of intelligence, which is incredible. But I wouldn't call them particularly smart, right? My cat is smart. She sneaks out of the house because she is not allowed to leave the house. And then she's always very noisy. I have a very loud cat. And when she sneaks out, she's silent because she knows if she makes a noise, I'm going to come get her. And she has to go back inside. She doesn't want to, right? And she'll spend the whole day outside in this vegetable garden out under my window, never making a noise, because if she makes a single sound, she knows I'm just going to walk right out and grab her. That cat's intelligent, smart, figured some things out. LLMs aren't. They're creative. So when it comes to infrastructure, one of the hardest things we have is that it's difficult to remember just what all the things are you want it to do. So if you listen to what people say, they can say things like, I want to deploy this Docker container to an ECS cluster in Amazon, or I want to build a VPC. And that sentence, almost everyone can write. And the LLM can translate that pretty effectively into infrastructure if what you feed it is a deterministic layer underneath, whose job is to take that information in a structured way and provide feedback to the LLM about whether what it's proposing is good or bad. So if you tell it how to propose that infrastructure, if you tell it, hey, here's the specification and here's how you work with it, and it maps one-to-one to the data you already have in the training set, then you can harness that creativity. You can put it with something that deterministically goes and proposes this infrastructure, evaluates it for quality, tells you if it's going to work or not work, and does that in an immediate loop instead of a long one, right? So it's not at the end of a PR cycle. It's at the moment that you proposed a configuration change. And suddenly, the whole thing works fantastically well. You can ask it questions. We do things with it migrate between architectures, deploy some stuff to EC2 instances, then go look at the instances, figure out the workload that's running on them, then translate that into containerized deployments on a different architecture. And it just works. And it's because there's this deterministic layer underneath it that System Initiative provides that is this one-to-one model of how all the infrastructure functions. And then the creativity is the LLM.
Hey friends, this is Scott. I'm going to take a moment in the middle here and introduce you to one of our new sponsors, Postman Flows. They let you orchestrate APIs, logic, and data visually. I've been chatting with Roderick. Roderick, what has been the aha moment for you when you were building agents with Postman Flows?
The first thing that I've noticed is that when you connect an API to an AI, then it really transforms what you can do and the capabilities that the large language model can do for you. So the aha moment for me was that very first connection and unlocking the ability of taking a AI, which was essentially transactional with respect to text in, text out, and changing it into something that was outcome driven, text in, actions out. And the way to do that was through APIs, and using all of the Postman APIs that are on the network today, over 100,000 plus, was really the thing that I wanted to sort of just drive more and more of.
Text in, actions out. Text in, actions out. I love it. Postman Flows. It's a powerful tool for creating and running AI agents and API automations. You can check them out at postman.com/Hanselminutes. So, in the interest of discussion, without pushing back, but also not trying to rat hole, You said creativity a lot, and I kind of like had a reaction to that because I feel like randomness isn't creativity. Like next token prediction isn't creativity. It feels like it's Mad Libs. And Mad Libs, they're wacky because we were four. And like, oh, purple underwear, oh, green eggs. So like if I had a site go down and I had an LLM that was responsible for getting the site back up, and I was told, don't wake me up. It's going to iterate. It's going to, it's going to kick the EC2 instance. It's going to, retry the build the Docker. It's going to do stuff. And just because it succeeded doesn't mean it was creative. It could have just been really, really persistent.
Fair enough. Here's why I think creativity is actually the right metaphor. Mm-hmm. So of course you're right that like at its most brute force level, it's Mad Libs. And it's better than Mad Libs because when given the right set of context and given the ability to attach it to deterministic tooling, what happens is you thin the layer of what the LLM needs to do. So the more you ask the LLM to do, the more it's like Mad Libs, right? So, and it's very paradoxical because the first thing everybody does when you approach AI is be like, well, let's just put AI everywhere. The magical intelligent robot's going to figure out how to do all this schmoo for me. And, now I don't have to get paged at night because it's going to wake me up because it's going to automatically fix all my infrastructure. And like, that's not going to work, right? Because the LLM's not going to do a very good job. And it's not because the LLM couldn't make good choices. It could. It's actually, they're pretty good at making the right next choice. Sometimes they'll make the wrong one, but you can correct them. But they're pretty good at making the right next choice in general. If what you have are systems connected to them that are designed to give them the feedback they need to know if the choices they're making are good or bad. And that's where we fall down when we're thinking about a lot of the modern systems we build. They're just not built to actually work with how LLMs function as technology. Most people just rubbed an LLM all over what they already had, right? They're like, well, I guess I'll just rub an LLM all over my code base and ask it to do wackiness. And you're like, that doesn't go as good as you hope, Like suddenly code quality is awful and suddenly all those things don't work. Well, it's because of the loop that was actually kind of bad for people, funnily enough. Like if you really think about the testing loop, like it's weird that you don't know that you formatted the code wrong till later, Why don't I know when I finished writing the statement that it was wrongly formatted? If I knew, that'd be better. And that would also make the LLM loop better. And then it would stop having so much garbage. So when I think about it as creativity, it's not because it's not sort of going at randomness, but that randomness is a big piece of what creativity is. A good definition of creativity is simply being able to create things that didn't exist before. And that's a thing that LLMs are pretty good at doing. Now, there's limits on their creativity, right? So if you ask it to create something truly unique that has never been seen before, of course it can't do it because it has no model for what that thing would be. But it would give you an approximation of it. And that is a creative act. A really good example of how to see this in motion is just ask an LLM to build you an image of a topographical map. Just say, give me a topographical map of Washington, D.C., and watch it produce a perfectly reasonable topographical map that looks nothing like Washington, D.C., right? That's not randomness. That's not Mad Libs. Like, it's got roads. It's got the little markers on it. It's got mountains and rivers. It's got all the things you need. They're just completely misplaced because there's no deterministic thing you attached it to that was like, hey, what's the topography of Washington, D.C.? Does that make sense?
Yeah, so I had a conversation about this morning with someone, and they were making a knowledge base, and someone on the call said, oh, that's just RAG. That's just retrieval augmented generation. Yeah. And, it's never a good idea to say just.
Just.
That's just a bad thing to say.
Yep.
But they said, well, no. So they said, no, there's a difference between RAG and being actually grounded in facts.
Totally.
Because one example they said is like you have two PDFs, and you're going to do RAG over them, and one PDF says a thing, like 2 + 2 is 4, and the other PDF says 2 + 2 is 7.
Right.
Well, if you just did RAG, you would not deterministically get the right answer. But if you grounded it in facts, the better tools you give the LLM, the more likely you'll be able to reconcile things like that.
Right. Why do we care how well an LLM does math without a calculator? It doesn't even make sense that you'd ask it to. It's going to probabilistically be wrong some amount of the time. It's never going to get to 100% correctness. If it got to 100% correctness, it's not an LLM anymore. I don't know what it would be, but it wouldn't be an LLM. And so, like, you know, we got to think about building those systems and exposing them in a way that allows it to do the work. It turns out that that is harder than it sounds, because in a lot of our domains, we haven't really designed them to be used in this way, right? They have to be highly parallelized. You have to have designs that mimic the data model that's in the training. So for infrastructure, if I build an abstraction layer between like AWS or Azure and my tooling, then I have to train the LLM on what the abstraction layer is and how the map works, and it gets it wrong. If I do it one-to-one, right? If the more I can make it just exactly what you say in your own documentation, it gets it right almost all the time. Mm-hmm. And, you know, but we didn't design those systems that way. We started building abstractions where we were like, oh, it'd be much simpler if I could interact, you know, generically over all compute, you know, and it turns out those things are terrible. Okay. I need simulators and review because you can't trust them because they're going to get it wrong. You know, like all this stuff you need that suddenly, you know, there's some analog in the way we did it as people when we were building those systems originally, but they don't map one-to-one anymore. Mm-hmm. And you have to rebuild and rethink how all that stuff works in order to make a system that actually works well with AI.
So we've gone from, I had my first build system was in, you know, a make file, and then it was XML, and then it was JSON, and then it was YAML. And now it feels like, and this is an oversimplification, but it's like, people are writing Markdown with emoji and calling it like their build script. But yeah, you're pretty close to doing that.
You can get pretty close to doing that if you have to think of it as layers of translation. So, you know, you shouldn't write your build script in a Markdown file and just run it and be like, LLM, build my software, and pray, you know, and just keep saying like, never do this wrong. You know, please don't make a mistake, LLM, you know, like that's not going to work. It's going to make the mistake. Your system won't build. That will be frustrating. But could you teach the LLM that there's a tool that's called build system, and it knows how to call the build system to create an application artifact? Absolutely, you can. And you can pass that off, and it's going to run that make file for you, and it's going to do the deterministic thing. No one needs a non-deterministic build process. That's ridiculous.
There we go.
But what you do need is a translation from plain English, which people can say. How many people can write the make file? Not very many. How many people can say, please build the software, please, please? Everyone.
Yes, right. So you're making a prose compiler.
Yes.
And it's a DSL. The DSL is prose.
Yes. Yes. And when you think about infrastructure, that's the kind of semantic layer that we've always wanted. What you've always wanted was to be able to go to have a coworker say, hey, we got to redeploy that software right now. And be able to take that sentence, hit enter, and have the system figure out what he meant. All this stuff we've been talking about how systems should be declarative and what we want, like what we've always wanted was that semantic layer of intent, that ability for somebody to say, hey, my intent was this. And the LLM is great at taking that intent, adding in the data it has about the system, what applications are deployed, what's the infrastructure look like? And it will use tools to go answer those questions, and then it will figure out how to deploy the app, right? Okay. And that is great, right? That's so helpful because tons of us can write that single sentence. Tons of us can do that. And most of us could also debug it when it breaks, because when you have a mostly working system, it's not so hard to see where the things fall apart. And that loop also gets better, right? You can ask the LLM to do it. Like it'll go fix production outages for you. It'll find, that are annoying. Like we had an outage that was caused by a configuration parameter that was basically off by one in how in the way that they had written it down. And the LLM found it in a couple minutes of just digging around, being like, oh, well, here's the error message. Oh, why would that be? And then it went and found the bash script that used that variable, saw that the variable was named one thing, looked at the configuration parameter on the other side, was like, oh, that one's wrong. It's off by one character. And then told us what the problem was. That was sick. We'd have found it, we wrote the infrastructure.
You would have found it. It just would have taken longer.
Well, yeah, it would have taken longer. And we found it by saying, this thing's not working. Here's the error message. We had somebody the other day who drew a picture of the architecture that they had deployed, but had not built any automation around. And then said, this is what I want put in System Initiative so I can automate it. And we said, great, send that picture to the LLM and tell it to discover the infrastructure. And he did, and it did. You know? And like, that is incredible, right? And that's because we put it against a deterministic system under the hood that knows how to discover infrastructure. Gotcha. It knows how to look at classes of things and find them all, you know?
It's a rich tool calling library.
Yeah. Yes.
Okay.
Yes.
So here's a question then. This might be a little philosophical. Let me see if I can get this out correctly. Please. If one makes a DSL, a domain-specific language, and they compile that into an intermediate language, and then they run that through a runtime, that's a pattern that has existed for years.
Yeah.
The DSL, though, is always the authoritative source. So if you do a clean and delete everything, you go and you point at the original DSL and you say, I can always recreate everything. Yeah. But if you write a bunch of prose and generate that intermediate thing, that intermediate thing now is deterministic by definition.
Yes.
But the prose is not. But if I deleted the intermediate thing, I could never recreate it exactly. I would get 99% or whatever the temperature is, right? I'd get a non-deterministic version.
Yeah, you get some kind of approximation.
Right. So arguably now the difference between prose-based LLM DSLs is that the intermediate thing that is now deterministic could be fed back into the system so that it might be even more deterministic.
That's absolutely what happens. Like,
really?
Now you have designed System Initiative. So what you do is
great. I'm interviewing well for you now.
You are. You're doing a great job. Yeah, no, it moves from being source code, right, to being data.
Yes.
And once what you're doing is saying, I have this rich data model. And what I can do now is program the data model instead of storing it in text files and then compiling it and then having it fuck with infrastructure. Instead, it's like, nope, I'm going to write a text file, right? Instead, what I'm going to do is send it to System Initiative. System Initiative updates a data model. And then that data model can go bidirectionally out into the world. So it can you can use the data model to change real world resources. You can use it to generate templates. You can use it to duplicate things. So like if you have an application and you want to deploy it from one region to another, you're just like, hey, I have it running in California. I want it to run on the East Coast. All you have to do in System Initiative is ask the system to make a duplicate of it and then set the region to the East Coast. And then you can hit apply and it will just redeploy it because it'll just rebuild it from all the same data. Because you have this structured understanding of exactly what the infrastructure is, its relationships to other things, what makes it valid or invalid, its documentation, your own corporate policy, all that stuff just goes into the data model. And then you use that model to feed the loop, both to people and to LLMs.
Fantastic. Oh my goodness. This has been delightful. I'm learning a lot. I need to go and explore the source code. I need to check out the SDKs, the APIs. I can find all of this starting at SystemInit.com. Yes. There's a whole rich documentation at docs.systeminit.com. Yep. And it's all open source and it's very good, very friendly pricing, certainly for hobbyists and people like me. I could get started for nothing. But even the hourly per resource is quite reasonable.
Hey, thanks. Yeah, you don't have to run any. Yeah, the free tier is 100 resources. Which is more than enough to run a small production infrastructure.
Fantastic. Well, thank you so much, Adam Jacob, for chatting with me today.
Yeah, thanks for talking with me.
All right. This has been another episode of Hanselminutes, and we'll see you again next week.